Hey everyone, welcome back. In this Houston Math Prep video talking about area between curves, we are just going to look at choosing dx or dy, when you might need to make a change, when you might need to look at it a certain direction. You may have some options, you may not. We're not actually going to work the integrals, but we're just going to talk about how to look at them to see the way they need to be set up. These three that we're looking at are actually three that we worked out in the previous video about area between curves integrating dy. So if you want to check that out, you can do that. But here, you can do this one first if you want. We're just talking about how to choose dx or dy. So looking at this first one we did in the last video, we had the line y equals x minus 1 and parabola x equals 2y squared. The idea here is, do I want to draw my rectangle vertically or horizontally? That will tell us if we're doing dx or dy. Remember, if we are integrating dx, that will be from a vertical rectangle. If we're integrating dy, that will be from a horizontal rectangle. So the direction that we want to draw our rectangle to make our life simpler will tell us if we're actually going to choose dx or dy. Here's the deal. Let's look at filling our region with vertical rectangles. If I fill the region with a bunch of vertical rectangles, the problem here you can even see as we start out, I'm going from the function to itself. In other words, if I'm drawing lines through in this way, one of my boundary curves is not even a function that direction. Think about if you were doing the integral with this function, you would integrate the top minus the bottom. In other words, the function minus itself, right? If the top and bottom are on the same curve. What do you think we'd get if we did the function minus itself? We'd get 0. So this is actually not an effective way to do this because part of, now over here that's not true, right? But if there's anywhere in the region where when you draw your rectangle that direction, it's going from a curve to itself, then it's not a function when you look at it that direction, and we don't really want to do it that way. We would say it's not simple when I look at drawing the rectangles vertically. So what I'm going to go back and do is actually look at drawing the rectangles horizontally. So if I start at the bottom and I start trying to draw some horizontal rectangles without messing it up too bad, here you can see that it's much clearer, right? I'm always going from one function to the other. I'm going to skip some space and jump up here. You can imagine if I draw through the entire area, I'm always going from one function to the other, so that's nice. So this is actually simple if I draw my rectangles horizontally, and so here we're going to choose to do the integral dy in this case, absolutely. Okay, so this whole idea of rectangles passing through the function more than once makes it not a function, not simple that direction, so we want to go this way. Horizontal rectangle again tells us integrate dy, and then you'll know your formulas need to be in terms of y in your integral, and you'll also know that your bounds then need to be y bounds, and everything then is just about y, if that makes sense. So that's how we would do our area for this one. Let's take a look at the next one from our last video, where we have the square root and the line and the axis, and those are our boundaries. So you can see my formulas here. For this one, if I start drawing my rectangles vertically, there's no problem, right? I'm going from the top is at the square root function, and the bottom of each rectangle that I'm drawing, these are skinny rectangles, right? I know they look like lines. Skinny rectangles. Go with it. Go with it. Okay, so no problem. It doesn't go through a function more than once. It's no problem. The issue, though, with this one that makes it a little weird is as soon as I pass this x equals 2 line, you'll notice when I'm trying to draw a rectangle through the region, the rule has changed, right? At 2. On this half, I go from the root down to the axis. From here, I go from the root down to the line with slope 1. So it's not that it wasn't a function, right? It was simple this direction. The problem with this one is that now the rule changes, and when the rule changes, so instead of going from root down to axis, you're going from root down to line. That means you're going to have two integrals. So this piece here, if we think of it this direction, would have to be one integral, because we have root down to axis, so top minus bottom there. And then this other one has different rules for what is top and what is bottom. So that would be a second integral for this piece. So you'd have to split it up and do two integrals. So if we don't do that and we look the other direction, let's see if it's just as bad. So if I go the other direction and I start drawing rectangles this way, everything seems to be a function. I don't go through a curve more than once. I don't go through the root more than once. I don't go through the line more than once. No problem. The other thing that you should notice here is no matter where I draw horizontal rectangles through my region, you will notice that I don't change rules. On the left side is always the root function when I draw a rectangle, and on the right side is always the line with slope 1. No rule change means that I can do this with a single integral rather than two. So it's probably better to do the area with my rectangles running this direction because I only have to perform one integral, no rule change. So if I have horizontal rectangles, again, this one is going to be a dy as well. And so that means I would then do, of course, remember, right minus left inside of my integral. We're being horribly unrigorous here, but it doesn't matter because we did all that stuff already before. And remember that these would then be y bounds once you've decided dy. This is why I choose my bounds last when I set up an integral. I want to figure out my dx or dy first. I want to figure out then, okay, if it's dy, all my formulas need to be in y, and I put all those in here, and then I go back and figure out my y bounds. Let's look at the third one from the last video. So we had these here. These were both already solved for x. This one's interesting in a different way. If I start drawing my vertical rectangles, you'll notice that I always have the one parabola on top and the other parabola on bottom. And so this is simple. If I run the rectangles that direction, no problem. That's great. Absolutely good. If I run them this way and I do horizontal rectangles, same thing. On the left side is always the one parabola, and on the right side is always the other parabola, and that doesn't change, and there are functions both ways, and no problem. So this region that we're trying to find the area of here in this one is simple in both directions. That's ideal. We really like those. That's great because it doesn't matter. Only this one, it does matter. Okay, if you remember, and we set up, I'm going to go ahead and just draw out what this would be. So if we're doing right minus left, remember that this one is going to be the integral of the right parabola, which will be the 3 plus 2y minus y squared, minus the left, which is the other parabola, 3y plus y squared. Let's say that you were like, well, you know, I really like dx better, so I was going to do this one dx. Well, a couple of things. First of all, it's already conveniently solved for x equals, so it's less work to rearrange these. It's also really, really difficult to solve these for y. If I was going to do my integral dx, then I would need to get functions of x. In other words, solve y equals and get some expressions that have only x in them. The problem is, how do we solve this for y? And the answer is, it's really difficult to do that. Because, well, I could move something, and then I have this, and you say, well, maybe I could factor, right? Out of y, but there's still no way to get y by itself easily using nice elementary algebra and have y equals and only have x on one side. So it's really not solvable for y. So if you really have to be doing your integral with the formulas in x equals because you can't get it the other way, then you have to do it dy here. So that's kind of this third option where you might be forced into dy or forced into a particular variable, not because it wasn't simple, not because the rule changed, but because it's just super inconvenient to get it switched around to the other variables. So no dx this way either. Not so good. You got to do this one dy as well. That's why they're in our dy videos, right? Okay, so to sum it up, again, when you're choosing dx dy, look at first in which direction when you draw your rectangles is the region simple, okay? Does it pass a line test when you run it vertically or horizontally? Are they functions? Okay, check. Maybe both direction it is and you have some options. Maybe only one way it works. Do the rules change? Remember from our second one, we went from down to the axis and then we went down to this line. So you might need a second or even a third integral, right? If the boundaries are changing on you. So take a look at maybe turning the rectangle the other direction. Would it save you from doing more integrals? And last, hate to say it, sometimes you just have no choice. Sometimes you can't solve x equals or you can't solve y equals because the way the formula is, there's just no nice way to do it, especially by hand. All right, good luck. Hopefully these hints help you choose dx, dy, and get those integrals.